everyone, I'm teacher Ijie. Welcome back to our YouTube channel. Today, we are going to talk about a past year question from NMOS 2018, which is about the geometry model. Let's have a look. So you can see that in the figure below, each side of the square ABCD is 12 centimeters. So you can see that we have the square ABCD. Then we say that the side is 12 centimeters. E and F are midpoint of AB and AD respectively. So you can see that E is the midpoint of A and B, and F is the midpoint of A and D. Then we say that FG is equal to 1 over 3 of FC. You can see that FG is over here, and then the whole line is FC. Then we are asked to find the area in centimeters square of the shaded region. So you can see that in this question, the shaded region is this triangle AEG. Alright. So based on the question, we know that E and F is the midpoint, which means that the length of all of these four parts, AE, EB, AF, and FD, they are just 6 centimeters. So to find the area of the triangle, we'll need to know the base and the height. Now, let's say AE is the base, and we already know that it is 6 centimeters. How about the height then? So the height is just we can draw a line from the opposite vertex toward the base. But how do we find the height of this triangle? It seems like we are not able to find it. Now, let's try to see if we can construct any geometry model to find a relationship here. You can see that there is a point G in the middle, right? The point G is in the middle of the square, and it is connected to the vertices A and also C. How about we try to connect it with the other two vertices B and also D? Now, we connect point G to point B, and then we connect point G to D. After we draw the line, can you observe any relationship now? So actually, there is a relationship here. No worry. Let's look at an example. So we'll start with a small rectangle. So now, what can we say about the relationship between the shaded and the unshaded region? Oh, they are the same. So, what is the relationship of the shaded region and the whole rectangle? It is half of the whole rectangle. Now, let's look at the second example. So you can see that this time we have a bigger rectangle right here. So again, what is the relationship between the shaded and the whole rectangle? Oh, it is also half of the whole rectangle. But why do we say so? So actually, we can try to cut our rectangle here in the middle with a horizontal line. Now you will see that it will form two rectangles. And each of the rectangle that we have found here is just similar as the rectangle in our first example. Now, let's look at our next example, which is an extra bigger rectangle right here. Again, what can we say about the area of the shaded region and the whole rectangle? It is half of the rectangle. This time we can cut our rectangle in the middle with a vertical line. Then you will see that it will now form two rectangles. Again, the rectangle that we have here is also similar to what we have in our second example. So the area of the shaded region and the unshaded region, they are just the same. So all of these examples right here, we actually call them the half model in rectangle. So what is the characteristic for the model in the third example right here? So actually we say that we'll need to connect a point inside the rectangle right here to all the four vertices. And then we will say that the area of the triangle formed at the left and also the right is equal to the area of the triangle at the top and also at the bottom. Now, let's go back to our question. So we learned about the half model. Can you see any relationship now? Oh, we can see that the triangle ADG and also BCG, they are actually half of the square. And also the triangle ABG and DCG, they are also half of the square. And you can see that for the triangle ABG, there are actually two triangles right here, which is BEG and the triangle that we want to find, the AEG. So we can actually say that the sum of area for the triangle AEG, BEG, and also DCG is actually half of the whole square. So now, let's try to calculate what will be the area. So we'll use 1 over 2 multiplied by 12 and again multiplied by 12, and we'll get that is equal to 72 centimeters squared. In this case, we are still not able to find the area of the triangle AEG. Let's try to observe our figure again. Oh, so you can see that for the triangle AEG and also BEG, they actually have the same base, which is 6 centimeters. How about the height? They also have the same height, which we can draw from the point G to the base. So we can say that the area of the triangle AEG is the same as the area of triangle BEG. This means that if we are able to find the area of the triangle DCG, then we just have to use the total area of these three triangles that we have just found. Then we just multiply with the area of DCG. Then we divide it by 2, we will get the area of triangle AEG. Again, let's try to observe our figure. Based on what we have from the question, we know that FG is 1/3 of FC. This means that the multiple of FG and GC it is 1 and 2. And you can see that these two triangles, DFG and also DCG, they actually have the same height. So this is actually the equal height model right here. We know that the multiple of area between the two triangles is the same as the multiple of the base. So you can see that these two triangles actually form a bigger triangle DCF, right? DCF. So let's try to calculate it. The area of the triangle DFC is actually just 1/2, and then we multiply by 6, and then which is equal to the 36 centimeters square. And now that we have these two information that we have just calculated, let's try to find our final answer for the area of the triangle DCG. Based on the multiple of base, it is just equal to 36 divided by 3 multiplied by 2, which is equal to 24 centimeters squared. So the area of the triangle AEG is just 72 minus out with the area of DCG, which is 24, and then we divide it by 2, which is just equal to 24 centimeters squared. And this is our final answer, right? So now let's summarize what we learned in this question. So in this question, we are trying to find the area of triangle inside a square, but we are not able to calculate it using the formula. So we try to construct a geometry model to find the relationship. So the first model that we found is as shown in this figure, which is what we call the half model in rectangle. So the characteristic of this model is that we'll need to connect a point inside the rectangle to all the vertices. Then we say that the area of the triangle formed at the left and the right is equal to the area of the triangle at the top and the bottom. The next model that we have found is as shown in the figure below, which is what we call the equal height model. For triangle of the same height, the multiple of the area between the two triangles is the same as the multiple of the base. So now I can try to do this practice question, and you can leave your answer at the comment section below. Right, you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video, and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.